Hello everyone and welcome back for the last lesson of our smart contract. In the previous lesson, we created our init function and also we created our create card function where we used events, coins, also object tables. In this lesson, we are going to create two more functions and that will conclude our smart contract. So let's get started. The first function that we are going to do is to actually update the description of this contract. For that, I will say public entry function update card description. First, we will have our DevHub object here as a mutable reference. Then we will have our, let's put this. Next, we will have our new description, which will be a vector of U8. We will have the ID because we need to give the ID to the table, then we can have the card and we can update the description. If we don't have the ID of the card that we want to change it, then we cannot update the description. And this will be a U64. Finally, of course, we will have our mutable transaction context. Since this is an enter function, we are not going to return anything. First, let's get the user card. For that, I'm going to say let user card. Here I will use object table, and from this object table, I will say borrow mute. So we are going to borrow this as mutable. We can either borrow this as mutable or immutable. Since we are going to update the description, we are going to change something. So we need to update this as mutable. And what are we going to update our devhub.cards, and we are going to provide the ID. This will bring the corresponding value for this key, which is our ID, and it will be from our devhub object, inside this devhub object from our cards. Next, let's check if the transaction sender is actually the owner of this card, because only the owner of this card can update the description of its card. So for that, I will say transaction context sender and our variables, equals as a user card.owner. So we are checking if the sender of this transaction is equal to the card owner. If this is not the case, I will return the error, not the owner. After we got the card and we check that the owner is actually the transaction sender, we can update the information on the card. For that, I'm going to say let alt. Actually, let's go like this. I will say let alt value, because we are working with options, and what we are going to have is actually we will return a value when we change something with the options in the Sui Move, and I will get this old value and I will delete it at the end. That's why I created a new variable here. So here we are going to use from option, swap, or fill. So if we don't have any variable, it's going to fill it. If we have some variable, it's going to swap it. If it's going to swap it, then we will have the value in the old value and we will delete it afterwards. Let's say mutable reference of user card.description, and we are also, before new description, we are going to say string UTF-8, not 7, and our new description. And this will update the description field of our user card with this new description, which is a string, because like the new description is not a string by itself, it's a vector of U8, but with this UTF function, as you know by now, we are converting this to a string. This is a mutable reference because we are actually going to change this part. So now that we have the old value, but how can we delete it? To delete it, we can say underscore equals old value, because this means that I'm actually passing this old value as a value, not as a reference. So now this will have the value, and since we are not using this or we are not doing anything with that variable, then it's going to be deleted. For any old value from an option swap or fill, you can use this method. Before deleting this, what I want to do is I want to actually emit my event. I will say event emit, and inside this we are going to say description updated, And here we have a couple of fields, which is name. And for the name, we will say user card.name. We have the owner, which is the user card.owner, or you can also go with the transaction sender CTX codes if they're not equal. Anyways, we have an error in the second line here. And finally, we have the new description. And we will have this string version of the new description, and that way we can emit our event. Again, it may look like an extra work while we develop our smart contracts, but it's going to actually pay back when we are developing our frontend. That's it for our update card description. Next, we have a function for deactivating the card. So it's not actually deactivating, but I think that the deactivate card makes the most sense. What we are doing here is instead of open to work true, we are going to make this open to work field of the corresponding user card to the false. For that, I will say public function, and this will be an entry function, not a normal function, big difference. And I will say deactivate card. We will have the developer hub as a mutable reference. It should be capital. We will have the ID. And finally, we will have this transaction context. It will be very similar to the previous one. We will get the card and we will check, and then we are going to update the field. For that reason, we can use the same two lines here. Now here I'm getting the user card with the corresponding ID, and from dev hub object using the cards field, which is our table. And then I'm checking if the transaction sender is the owner of this card. If not, I'm returning the error, not the owner. If these conditions are satisfied, then I'm saying user card dot, not description, user card dot open to work equals false. Here, since this is not an option and we are not using swap or fill, there will no value be returned to us. So I'm just updating this part and I don't need to delete anything else. This will be our deactivate card function. We just have a couple of errors when I save the file, and that's because I also said like with lowercase here, it should be a dev hub because this is my variable name. And this is the name of the struct. If we check it again very quickly, as you can see, we have our dev hub. So this is the capital, and I'm using the lowercase for the variable. As you can see, if we don't put the name right, then we have a lot of problems. Now, let's create one extra bonus function. I know that I said that we are going to have two functions, but I hid this one as a bonus, and it will be a pretty simple function. It will be a public function where we return the card from the table. So we are going to give the ID and we are going to return the corresponding card from the table. It will be a public function. It won't be a public enter function because we are going to return some value, and in the enter functions we cannot return any value. And with these enter functions we can actually update some value on the blockchain, but I will not update any value. I will simply return developer card, so there will be no need for an enter function. So let's say get card info. We will have two parameters. First, dev hub. This time I'm careful. It's a uppercase, and as you can see, it's not a mutable reference like the one before because I'm not changing anything. I'm just getting some data. Also, we will need the ID to get the corresponding developer card. As a return value, actually, we are going to return a tuple. So we are going to return multiple values so that we can also see how we return tuples. But we have a lot of values to return, so I will quickly paste it. Now, let's look at the values that we are returning. And as you can see, it doesn't make that much sense if we don't know what is the dev hub object. We have string address, string URL. This string corresponds to the name. Then we have the owner, then we have the title, image URL, description, years of experience, technologies, portfolio, contact, and finally open to work. So we are actually returning every value that we need to create a card. Now let's start our function. What we are going to do is really simple. I will say let card equals object table, and I will borrow but not mutable. let's say devhop.cards and ID. And next, we are going to return the corresponding values from this card. I created my tuple. Sui Move is like Rust. So instead of saying return and putting semicolon, I can simply don't put a semicolon at the end, then it means that I'm returning this value. And the values that I will be returning, card.name, card.owner, card.title, now I have the every value that I need to return. So what I have is a tuple, and what I'm returning is a tuple. The main idea here is that I can return multiple values. I don't have to return one value. It looks okay. Our contract is finished. Now let's save it and look if something's wrong, but it looks okay. Now let's have a quick look in our contract. We imported the necessary parts here. And then we have our constants. First two is an error, and the last one is just a check. Then we created our dev card, and we also created a separate structure where we have a table, and in this table we have our dev cards, and we shared this object so that anyone can manipulate it using our functions. Then we created two events for card creation and card description. And then we created our initialization function where we share the DevHub object after its creation. Next, we had the create card part. Here, first, we get the tokens, the amount of the tokens. We check if it's enough, then we publicly transfer this. After that, we increment our counter. Then we get an ID, and we use this ID in the event and also in our dev card. For the event, we use UID to inner ID to actually convert this new UID to ID. Then we implement the necessary field for our event, and again this event for the front end. By saying this event for the front end, whenever someone uses this function, then this event will return with these informations. Then we created our developer card with the corresponding fields, and we added this card to the object table. Next, we had a function to update card description. And here first we got the user card, and then we checked if the owner of this card is actually the transaction sender, because only the owner can manipulate his or her dev card. If that's the case, then we use the swap or fill function from the option. We said that this is going to return a value which we need to delete. Then we emitted the event. Finally, we deleted the value using this convention. Then we had a function to deactivate the card, which is very similar to this function, where we get the card, we check the owner of this card, and then we update the corresponding field. Next, we had a function so that we can retrieve some data for our front end, and we said that get card info is the name of our function. We had a tuple, and we had a lot of values in tuple. Got the card. For this case, it wasn't mutable, so we used immutable because we are not changing any variables or values. We are just returning what we have, and then we returned this necessary variables. It's not a very long and complex contract, but what it does is substantial if we look its size. It's not that easy maybe in the first look, but after we got used to it, since it's given to us with many functions and many possibilities, I think it's pretty straightforward when we compare this to the other blockchains and how we develop smart contracts there. And also, it's very easy to create NFTs, or let's say assets, on Sui blockchain. What we need is, again, for these assets, which we call Sui Move objects, are the key and this ID, so that we can have our own unique objects with different IDs that is generated for us using this UID from Sui. I encourage you to go beyond it and manipulate this contract, work with this contract, and see what you can change, how you can make this better. I'm really curious about what you are going to come up with. And during this process, again, if you have any questions, that you can ask on our Discord channel. Thank you very much for listening to me on this video, and I hope that you are going to have great contracts for your own.